This is the Soils for Life podcast. I'm Ellie Court. Dr Susan Orgill is the Chief Scientist at Impact Ag Australia and a leading soil scientist with more than 20 years' experience. She specialises in soil health, carbon farming and regenerative agriculture, delivering science-based strategies that improve farm resilience, natural capital and climate outcomes across research, policy and sustainability initiatives. Suz has long been a friend of Soils for Life. I think she's one of the most interesting and impressive soil scientists working in agriculture, and I've been meaning to get her on the podcast for some time. So please enjoy this conversation with the one and only Suz Orgill. All right, well, let's start simple. What is soil?
Okay, so first of all, it's like music to my ears when people say soil, right? And I think soil there's no coincidence that it's very close to the word soul. It's the minerals, the microbes, the air, the water, and the organic matter, which sustains us in everything we do. Always say if you eat food, breathe air, and wear clothes most of the time, like you're supported by soil.
Yeah, and I mean, what do people get wrong about soil?
I 100% think people don't realize that it's alive. I think the most exciting part of my job and my career has been like literally digging holes, which sounds like a really not exciting part of a career when you've done a PhD, but it's absolutely just digging a hole and chatting with whoever it is about what I'm seeing. And that can be with other soil scientists, it can be with farmers, it can be with investors, it's with kids. And it's the same thing I'm talking about, but seeing their eyes light up when they realize that there's different colors and smells and it feels different and there's life in there and the life is influenced by what we do. Like I think people just don't realize that. And like the issue of calling it dirt, like my kids from a very small age have always been when someone says dirt, they're like, no, it's soil and it's alive and it's so important and it's really exciting.
Yeah. What do you get excited about finding in the soil? What are some of the critters that always light your eyes up?
Oh, it sounds like it's obvious, but like I love worms, absolutely. And so maybe reflecting on the whole kid thing, like I'm talking soil worms, not butt worms, as my kids refer to them. But I love worms. I think it's just, and I kind of feel like we've almost drifted away from what we can see and can appreciate in the soil in terms of seeing life in the soil, being a worm. What type of worm is it? Termites, if you're not in worm country and you're more in ant and termite country, when we move out into the rangelands, just anything that is important in physically moving soil around, creating space in soil so that plant roots can move through. When we're looking at plant roots, looking at mycorrhizal fungi, for example, seeing that in soil is super exciting. On Monday, we were digging holes on the Monero, had a group of farmers, and just like visually seeing these almost like root and microbe highways zooming through these really tough Monero, billions of organisms. You've got nutrient cycling, and our real focus on Monday was around building topsoil in the subsoil. So, like, how do we grow the soil up and down and put some of the all the good stuff that we're used to seeing when we take a handful of surface soil, but building that deeper down as well. And the way to do that is through microbes and the big kind of like big soil tractors, like for that bioturbation, is are those big organisms like an earthworm or a termite. And I think it's funny when I first started in soils, it was very much kind of recipe style agronomy that I used to do. I used to run around and we'd do workshops and dig holes and look at what we see. But it was always we'd get to the third workshop. It was 4 workshops in the series. The third workshop was always the recipe. So it's like, right, here are the numbers and here's how you do fertilizer calculations and what it means and things. Fourth one was around farm planning and soil biology. And I feel like people were more excited seeing and understanding why a worm would create a little channel deeper down and seal it all off from the environment and kind of exude all its gut contents to survive, and why microbes do what they do, or why we see this. And I'm like, bloody hell, like the previous workshop was literally giving people calculations and tools to either save or make tens of thousands of dollars, but they were just inherently interested and connected to the tactile part as well, like what they see, what's a good indicator, wanting to know about worms. The amount of times I've been asked to spell the word actinomyces, like dead set, you're never going to need probably to do that if you are not in my line of business. But people are like, how do you spell that? And they're writing it down in their the notebooks which farmers keep in their top pockets. And like, yeah, and it really, like as a young soil scientist back then, obviously I'm not talking about me now because that's got that ship
Still
has
young,
sailed.
Suz.
That ship, it's all relative. It is all relative. But like for me, I was really curious about that because I had kind of been taught that it's all around farming is, and of course it's around making money and profit, and you need to have productive landscapes to make profit, but also just realizing that connection and understanding. As a scientist, I look for patterns in data and I look for patterns in trials and I'm looking for patterns. And this realization that farmers are doing exactly the same thing. They're looking for patterns and observations. So digging a hole and finding a worm, for them, there's a pattern that reinforces, all right, what did I do? Or why am I seeing it there and not there? So it was an
Mm.
awesome learning experience delivering those workshops for sure. For
Well,
me.
and I guess I don't see why we can't have our cake and eat it too, why we think that farming has to be all business and only business, nothing tactile, but also nothing exciting and enthusiastic and playful. I think a big part of what we've seen when we've done that sort of a workshop is just the enjoyment that people get from seeing life in their own soil. And often it's people who have been farming in a way that they hope will build life in the soil, but they've never really seen it up close and personal. And it's so exciting to see that, yes, that is happening.
Yeah, 100%. And I think there was a bit of a pressure, there was a bit of a movement, I guess, at some stage just to absolutely evidence is everything, like speaking to a scientist, right? And so like that's my mantra is evidence-based decision making. But just remembering that, lack of evidence isn't evidence that something doesn't work. Like always, I always come back to that. And also evidence can be in different ways and different forms. Like what makes me very nervous is where people are quite happy to make recommendations based on a bloody set of numbers that they get emailed and having never spoken to the farmer or set foot on a place, because you wouldn't do that with like a blood test result, or you wouldn't do that with any other test, right? Like you've got to see the number in context. But also I feel like maybe for a while there we were expecting farmers to be a little bit more disconnected from their sense of observation, and like we're working in really complex systems where
Mm.
I think some of the feedback when I go on farm and people are like, thank you, you helped me unpack, but I understand that now. And I'm like, I just asked you questions. I actually didn't even tell you anything. You knew it. I just helped you arrange the information in a way that helps you make the decision or understand what was happening. And often that is the case. It's just
Mm.
asking the right questions. And that's where I think science also plays a super important role.
I often think of the example of a CEO of a business that's selling things to people, and we would never expect that they would make decisions based on a set of laboratory tests or even a focus group with the people who they think might be their customers, right? The people that you're selling to are part of a complex social system, and whether they're going to buy the thing that you're manufacturing or not, and in how many numbers and how quickly, like that is a complex question that you're not going to get perfect answers to from one or even lots of scientific measurements. You're going to have to make a judgment call, and there are lots of different factors and evidence that you need to bring in to inform that judgment call. But you would never expect a CEO not to, at some point, using all the information they've developed, make a judgment call. And I think farmers
Yeah.
are very good at that, taking all the evidence they have, but not expecting that they're going to get the answer from a test or from someone else. They make the decision, they're in control.
Yeah, yeah, I'd certainly like to think so. And I just want to change my favorite soil organism for two reasons. A, because I'm not waving at you. There's a bloody fungus gnat that is like crawled out of my pot plant here. And that leads me to, and I can see springtail on the screen as well. I think springtails are my favorite soil organism at the moment. And the link with fungus gnats, do you know that link?
Yeah, no, I don't know about that link. And I probably have experienced fungus gnats in my own home, I'm sure, but I don't know a lot about fungus gnats.
Yeah, right. So fungus gnats, as the name indicates, they feed on fungus and mold in soil. And so sometimes if you're not on top of your watering of your pot plants and things, then you'll get those annoying little bugs. And it's like you can't kill them. They're like little freaking bug ninjas that zoom around my office, which I hate. But What I do with them and what you can do, coming back to springtails. So what springtails eat is they eat fungus and mold, and you'll see springtails in your compost heap. They're the little white kind of tiny little flecks, and they're called springtails because their little tail wraps underneath them, and then when they spring it back, that's how they move around. So you'll see it in your compost bin. So if you've got fungus gnats inside, what you can do is you can harvest springtails from your compost heap by putting a mushroom in there for a couple of days. They love going on a mushroom. And then you put the mushroom, once you've got a whole nice little colony of springtails on there, the little white specks, you'll see them. You can see them with the naked eye. You can float them off in a bit of water and just float them off into your now biologically active pot plant if you're bringing springtails in, and it'll get rid of the fungus gnats because it gets rid of their source of food.
I
But
love
obviously,
that.
yeah, springtails, or calendula is their proper name, are super important in soil also.
Yeah. Also, I think my favorite soil organism after last year, or maybe it was the year before, we brought a macro photographer from the UK. His name's Frank Ashwood to Australia. And we took him to 6 farms around the country, and he dug up soil on every one of these farms and just took photos of what he found, blown up to a magnificent detail and size. And the globular springtails in particular are just the most beautiful things. Like with the naked eye,
Yes.
it's a little dot bouncing around, right? But
Yeah.
oh my God, the colors are incredible. And the shapes, they look like little
I'm
sort
gonna
of
have to check
tanks,
it
little
out.
round tanks. Very
That's
cool.
so cool, hey? Like, it's really cool. On my walls, like, it's a reflection of who I am. I have these beautiful, there's a visual ecologist called Avita, and I can't think of her surname, but I've got two of her artworks on my wall. And one is a compost one, and another is a soil one with kind of where you can see the structure of carbon. If you haven't seen her work, freaking like brilliant. And in terms of visualizing artistically, not through the photo that's captured, which you've just spoken about there, but in terms of soil life, she's just a genius. I love it so
Oh,
much that I look at it every day in my house.
we'll have to check her out. So I want to change tack a little bit, but sort of on the same line of your career in soil science. And we caught up at the Regenerative Food Systems Conference in Perth, and you gave an amazing presentation. And one of the things you said in that presentation was that you are a recovering reductionist scientist. I'm interested if you could explain what you mean by that, and when did that turning point happen?
Well, that is funny that I said that. I think my style of personality, my style of science has always been recognition that I don't know everything everywhere all the time. Like, do not tell my husband that, because according to him, I do know everything. Um, and I think I'm very thankful that I was trained in a really reductionist way, because the importance of that is being able to isolate and understand processes and mechanisms. But I'm very much someone who likes to take my science to the field. So I'm an applied soil scientist. And when you get outside of the lab and outside of a replicated trial, and you try and put that into something that farmers are going to be able to use and understand how you can stretch that and scale that to get and enable impact on farm, I very quickly realized that there's these complex systems, obviously. See, I'm a bloody slow learner. See, it took all that for me to realize that there's complex systems, and some people just start there, but for Susan Orgill, it started different in a different place. And just understanding that I'm not always going to be able to control everything in my science and in my trials in my life. But really, it comes back to saying, okay, like, how different things happen at different scales. There's a huge amount of complexity that's going to lead to different outcomes, and being really comfortable with what I don't know and trying to use the science training that I have to try and understand what might work for other people as well in other situations. So I think that's where I've got to. Like, it's hard to publish if you're not in that reductionist sense, right? Like, your peers, for a very, very good reason, have that framework, right? Because it's really around evaluation, critical thinking, informed choices. But I think the two can go together, right? So, and the two must go together. And that's where we'll really start to kind of move forward.
Yeah, I mean, are there research methodologies that are emerging that are well suited to exploring that complexity that's found in agroecological systems?
Yeah, absolutely. And there's bloody decades worth of data and research published on agroecology. I think from my point of view, my style of thinking isn't that's I didn't start thinking that way. When I think sometimes the two fields, because they've got different approaches, haven't always worked really well together. And I'm always just want to be challenged and want to be out there. And I like for some of my colleagues, I'm a weirdo in the traditional ag space, but then there's like a whole space that I'd be like the most traditional kind of conventional scientist they'll ever come across,
Mm,
which probably isn't the case either. And when I'm speaking with them, it's almost like mind yoga because like I'm trained just to think in straight lines and understand why that straight line or think in that style of pattern. And yeah, I think it's exciting. So yes, absolutely. There's theories and frameworks and research methodologies to think that way. It's not how I was trained. And so I try and
mm.
bring the two together.
Well, I think that's a rare thing because people do tend to feel more comfortable sitting in a camp where everyone else is doing the same sort of work as them and talking in the same sort of ways as them. And we do need those people who bring different ways of thinking and understanding together to ultimately give farmers the best information to make better decisions, right?
Absolutely. And as I said before, like it's just about the type of evidence. And just because something hasn't been answered or we don't have evidence yet, that's not the same thing. It doesn't work. And sometimes I think the metrics that we've chased traditionally, and I am absolutely guilty of this, they're not the only metrics, right?
Mm.
So just because soil organic carbon doesn't increase when you do X and Y doesn't mean that you're not getting all of those other benefits, right? Still do it. And I get really, really nervous when I'm asked. My comfortable place is a metric, but I get very, very nervous when I'm asked just to give one for everywhere all the time.
Yeah. Well, to that point, the next question I was going to ask you was how, given that broadened view of things, how do you now define what makes healthy soil in a farming landscape?
People people and plants make healthy soil, okay, these days. um, and I think in terms of we've got this proven path forward already with lots of evidence, okay, so I think the evidence thing is there in terms of um, healthy growing plants which are optimizing their photosynthesis with very little soil constraints, contributing the energy from the sunlight for the animals that we graze or the crops that we're growing, and below ground for the microscopic livestock which we're depending on. That creates a healthy soil. And there's not a metric for it, and there's probably not an end point for it either. I think, I mean, I live in soil carbon land, so for a long time they were talking about, this point of saturation. And then that gets confused with equilibrium. And then that gets confused with, I'm just like, okay, like, so it's comfortable for us to say, the number is 100. And once you get to 100, that's it, you're already there. But we know there's evidence that's not the case. And I think even those scientists that say it's 100 or whatever that is, and so saturation being that the soil has a limited capacity to store and stabilize carbon. But then there's really exciting information out there in the peer reviewed literature which shows that you can have carbon on top of carbon, almost like these little mini skyscrapers which are being built out of organic glues, stabilizing carbon in the soil. Or if it's in that microbial detritus form, the humic form in the soil, that's nice and stable. So I feel like it's good to have really easy things for us to say there's a point and it's attainable or it's not. Equilibrium is another really good point about that. Like you'll absolutely, just like a forest above ground, below ground will reach equilibrium in terms of its soil function and its soil organic matter or carbon level and its soil organic matter turnover. But absolutely, like anything above ground, you can have a disturbance, a good disturbance or a bad disturbance, and change that equilibrium. And I reckon that's the exciting thing about farming and science at this stage is that those styles of thinking are coming together.
What I understand of ecology is that if there's one constant, it's change in
Yeah,
ecosystems. So even though I think a lot of people do have an idea of an ecosystem, certainly a very healthy and functional ecosystem as being in that balance, that equilibrium, it's never not changing, right?
yeah.
That is the constant for ecosystems. And so yeah, that kind of goes to what you were saying. But so you mentioned there plants are at the center of creating healthy soil, and to create all of those wonderful things that make a soil healthy, you need living, growing plants. But you also said people. So could you
Yeah.
speak a bit about that part of what makes healthy soil?
Yeah, so people are important because people influence what plants are growing, how long they can grow for, the environment in which they're growing. So if they're experiencing constraints, and people can help plants. So that is definitely, I think, how we've got that influence between people driving carbon into the soils and retaining carbon in the soils. And really, when we look in the literature, the diversity of carbon that you can grow, the diversity of plants, there's lots of evidence around that. Keeping plants in that stage of photosynthesis, resting plants so that they have space to grow and that you get new species coming through, and the rest and recovery is almost more important in a lot of cases than the graze itself. That said, that the graze is a very important tactical tool as well. Around bringing organic inputs to the soil. So some of those, getting the next level of equilibrium happening. So people can influence all of that. And
Mm.
also, obviously, absolute king is ground cover.
Yeah. And you are now working, well, for a long time, you've been working with farmers to help them build soil carbon and build landscape health and productivity. What are some of the major barriers that you see that prevent farmers from doing the things that might improve soil health on their farms?
Like the first point that comes to mind is this perception of uncertainty that it's going to not work, or it's going to cost too much money, or it depends on too many inputs. So I feel like there's just so much uncertainty there in the farming community, and that community being both the farmers themselves and their advisors as well. And where a lot of the research has come from traditionally has been through industry style funding that perhaps wasn't necessarily chasing an indicator of increasing soil health for resilience. So it was always referencing what I said before around this individual indicator. For example, it's yield or it's this and that, not thinking that a farmer manages over multiple seasons. Not just that one point in time. So, soil health is, I guess, your friend in the good and the bad. And we see that. And I think that's the shift that needs to happen, and realizing that it is mainstream now to have practices which improve soil health, like soil friendly practices. It doesn't need to be a weird label of whatever, but we all agree on the science behind plants photosynthesizing, putting energy into the soil and protecting it there. And we know that that can increase the soil's ability to supply nutrients and water and have air. And I love presenting to farmers always, and I've always loved that. I really love presenting to agronomists and meeting them where they're at, so they understand that it's not somebody like dancing nude, like absolutely dance nude in your field or whatever floats your boat. But it doesn't have to be that, right? It's
Mm.
just coming back to what we're trying to influence and over what time scale. And I think there's people who will be willing to understand and think about that. The other day, someone was saying about young advisors in this space are more open minded. And I don't know necessarily that I agree, because sometimes I'll sit in rooms doing training with agronomists, and it's actually the older ones that are like a little bit softer and realize, actually, yeah, because they've coming back to that, we all think in patterns, like they've seen this pattern and cycle, and they're realizing that bloody just pouring more on again and again and again.
Mm.
We're not getting those increases anymore. So what is that new mindset and shift that we need to have? And so I think just being really open minded in that space it's the exciting part. And I think the big barrier, so yeah, the really long
Yeah.
way to say uncertainty, perhaps
Yeah.
in their peers in the farming community. And it's moved just to now have acceptance that we need to farm over a different scale and actually value what the soil can provide for our productive landscapes.
Yeah. Yeah. So what is this is probably a very big question, but like what is the current state of the evidence around how different practices can improve soil health and therefore ecological function and production? What do we know with great certainty, and what are we less certain about?
Yeah, I think we know a great deal, and that's why I just find it so frustrating. Like we've got in the kind of complex ecosystem, ecological agriculture space, and regenerative ag space, we've got decades worth of data on that. And maybe those scientists haven't spoken to the more kind of more traditional agricultural scientists and soil scientists. We've got decades worth of data on practices to build soil organic carbon that's going back around thinking about, again, how do you influence the plant? So what you plant, the length and duration of pasture phases in cropping systems, crop stubble retention, how you treat that stubble, digesters. There's exciting evidence now coming out in the peer-reviewed literature around biostimulants and humates. It's there, and I think a lot of the people who were those early movers and shakers, we've got the way of understanding now in the literature why and how it works at a very, very fine scale. Like, most people don't give a crap about that, right? It's like, does it work or not? But there's like a lot of us that need to be comfortable about how it works and why it works. So I really think we can move the conversation forward, and absolutely we need to, because the more we start funding improvements in soil health and enabling farmers and advisors to be comfortable in that space, and the less we start spending on mitigating when we're not doing it in terms of practices which are dehydrating our landscape. Like, that's just, it's phenomenal that we're still kind of there in many cases, but you can't
Yeah,
change everyone all the time. And so just keep going with the people that want to listen and want to do things differently. But
yeah,
I don't know, I think still making people be comfortable with where the literature is still super important to me.
yeah, yeah. And is part of the challenge there that unpredictability of how a particular practice or a particular set of practices will play out in a particular context? Because I think people struggle with that, right? That means you have to move from a mindset of, I'm going to do this thing and it will have this outcome, predictable, to, I'm going to try this thing and maybe a
Yeah.
few other things all in combination, and then I'm going to see what happens, and then I'll plan to tweak and adjust and, try and refine until I get something that works. That's quite a different mindset.
Yeah, it absolutely is. And I think so. If we start at where the science is, I'm going to say that, and then I'm going to tell you a cake analogy. And I've probably said this to you before, Elliot. It's just around, so you can give the same cake recipe to 5 different people, you get 5 different cakes, right? It's the same recipe written down, right? There's different things that go into that, and some will be good and some will be bad, and some will be a success and some won't. And for some reason, we expect that you can give something a label in agriculture, and whoever picks it up, whatever their cooking experience or farming experience, or no matter what their oven's like or their gear's like, that it's going to be exactly the same. Like, it's kind of a nonsense approach, right? You think, well, how do you become a better cook in that sense? So it's around who you surround yourself with. It's around understanding what your systems are like. Does your oven run a bit hot? Does it run a bit low? Does it need to cook it for longer? Do you need to like, so I think there's so many different things there. And what we were talking about earlier, it's, I feel like for a while we almost took that away from the farming community. It's like, no, we'll tell you what the numbers are and we'll tell you what you do there. And here is the mix. And there is absolutely a role for that advice. But there's also a role for people to say, okay, how does that fit in your landscape? Like, what do you know about this? Like, a country is always wet, or it will always get hit by frost down there, but it doesn't at this time. Or, those kind of incremental changes, and understanding that one of the things you can't change a lot of things about landscapes, but what you can change is things above ground in terms of plants, pastures, crops, trees, how you treat them, and things below ground. And so if we're influencing those, and understanding how the practice or the labeled practice fits into that landscape, then you're going to continually learn and make it kind of the practice that works for you. So I can't remember the name of the author, but I can send it to you and people could look it up. So there was a paper that I had to review earlier this year, peer-reviewed paper, and it was a meta-analysis. It's where they look at a whole range of peer-reviewed published studies and looking for trends in that data. And it was looking at crop response under different critical phosphorus and nitrogen levels. Okay, so when you do a nutrient trial and you're looking at for that critical threshold for optimum biomass or yield, what you do is you hold everything else in your trial, reduction of science, hold everything else stable, and all you change is that one lever, right? So you're just changing the rate of nitrogen or just changing the rate of phosphorus, right? And you get this beautiful curve that you would have seen it at many updates, cropping updates, right? And then that will tell you that if you want to get 80 to 90% or plus biomass or yield, you need to apply this amount of nutrient on that soil type. It's how you do it, right? Anyway, so what this meta-analysis did is it looked at trials which, and I think this is almost like the regen ag approach, right? It said, what if it wasn't not 100% of that? What if you applied 80 or 50%? what do you do in terms of influencing below ground soil function? And they were looking at the accumulation of soil carbon and root exudate, so that really rapid turnover of soil carbon and root growth. And what was the penalty above ground, right? Because that's what we see and we think about, it's what hits our bank balance most immediately. And it showed that if you went back to that 80 in these meta-analysis, 80 or 50% of your critical nutrient threshold for a range of crops, I think it was over 30 different studies that they looked at, you only had a yield penalty of 2%. So you've saved potentially half your fertilizer input. I'm not saying for everyone to go and do this everywhere all the time, right? What was interesting though is you think, why? Like, why does that happen? And what they found is that the plants started doing what they were biologically designed to do better over millions of years, which was grow stronger, deeper roots to explore a greater volume of the soil. And there was greater root exudation. So there was actually more carbon going into the soil. And I think that's really interesting. I think sometimes where people think about backing off some nutrient inputs, and absolutely it's not pulling the rug out, it's like just kind of slowly edging away from it, from my experience, plants will have the ability to respond to that. And I think the other thing is they found that the noise in that response is the noise of reality, right? Because the trial that I explained at the start of this example, where you hold everything else right in terms of climate, soils, there's no pests or diseases or bugs that you're bloody dealing with or anything like that. You're only changing the nutrient. That does not happen anywhere ever, right? Like we're dealing with multiple things. So I got a lot of joy out of reviewing that paper. And more important than me getting joy out of reviewing it, I think it let us realize that it is okay to take science and think about it in a complex system and try and make a better decision for you.
Yes, that is so fascinating. And that goes to the question I was about to ask, which is about how what we know about improving soil health and what people, farmers, can do with strategic use of plants to build soil health and to build that underground community, how that can influence production and profitability. So, do you want to talk a little bit more about that? I mean, that paper obviously goes directly to that, but more broadly.
Yeah, absolutely. I think from it has always been at the center of kind of my work and my career. It has to be applied. You need to be able to do it in the field. I'm always like, how do you actually do it? And you've got to be able to make money while you're doing it, right? So it's around profitable and productive landscapes. And I 100% see the evidence these days around this nature positive farming. So whatever kind of we're going to talk about it, but how do you use the resources that you've got, being the sun being a resource, the water that falls on your crop or pasture, the water that's hopefully infiltrating because of your management into your soil, and then that green water storage. So water in soil and plants in your landscape. And that's going to influence things like water and temperature loss from your field. And so making it profitable has to be at the center of it. And profit is, I guess, a consequence of a couple of things. It's inputs and outputs, right? So if you can reduce your fertilizer inputs in a safe way and still optimize photosynthesis going into biomass available for your livestock, and you're managing that well and keeping ground cover, or in terms of crops, that's really important. There's evidence around how we treat and use stubbles in a profitable way as well now, so that you can minimize your nitrogen input when you're going back into the crop. For decades, DPI did work in New South Wales and Victoria around the health of pasture phases in cropping systems. And I think we're seeing the profit around that as well come back. So if you've got an agronomically desirable increase in soil organic matter building up during that pasture phase, and then you go back into the crop, you can save money on your nitrogen input, and you've got a soil which has better structure so that it can store more moisture and be buffered against some of those temperature extremes, so you can have less frost risk, as an example.
Yes, and that goes to another lens on production and profitability, which is around resilience and the vulnerability or resilience of the crop to pests, to disease, to conditions. How do you think about that? Because we often hear people talk about making a shift to a more ecological or regenerative approach to farming and finding that their profitability is more stable over time, even if they don't necessarily have those bumper years.
Yeah, absolutely. And I think that is key. And we've spoken about that now a couple of times. It's over which time frame and what you're thinking as well, and what some of your metrics are. And time is important. Like farmers are terrible at counting the value, the price on their time, like how much time they're spending spraying, how much time they're spending that. Like you don't count that. And if we bloody did, they'd be working for 2 cents an hour, right? But it's an important point. I
Well, and the health implications of handling some of those inputs as well, I think is worth considering too.
Yeah, absolutely. So I think there is a balance, and in that, and you've already kind of nailed the answer to the question in the question, but I might share an example of earlier this week where someone was talking to me about there was a robust discussion around the role of continuous grazing or set stocking against rotational grazing. And bloody data was on the screen that wasn't helping in terms of the benefits in soil carbon and in productivity of rotationally grazing, just giving some rest to the pasture. And we weren't going anywhere there. And this particular person was like, but it all looks the bloody same in a drought, Suze. And I was like, yeah, maybe it does. But does something respond quicker afterwards? And he's like, well, yeah, no, they'd probably come back and they'd probably hold on for a bit longer. And like it's all it's like sometimes I think we're our own worst enemy, right? Like, and it's really hard giving a presentation where people want to hear what they want me to say. And being in that uncomfortable space, it's everyone makes decisions for different reasons. I think we've got a lot of data now around the soil health benefits of grazing management and organic inputs and efficient use of fertilizers. And the leading advisors and agronomists, the ones that share and sell knowledge, not just products, they know that too, right? They're very, very good. They're far better than I am at that advice. So
Mm,
I
mm.
think it's coming back to being the climate is almost forcing our hand in making some of these decisions now around the value on green water being in your soil or in your plant, not bloody running off. And there is a value in that we know, which will be realized in the yield and in the soil carbon increase.
Mm. Where do you hope or feel that conversations about agriculture need to go next?
What I'm getting a lot of joy out of is the connection of many people to where their food comes from and how it's generated and made. And I know the next thing is always around, will people pay more for it and what's the price premium? And I think that is not a discussion for a soil scientist like me. It might be for another soil scientist. I think soil and food security is like just such at the forefront of many people's minds now. We're so lucky in Australia that we have a national soil strategy. We've got organisations like Soils for Life, which have been brokering knowledge for many, many years. I think soils has a very high profile in Australia. We're very lucky that we've got the ACCU scheme, which is for some people a great enabler, if that's their thing. So we've got policy that supports better land management practices, and that is really important. Where I think we need to continue to go is to make sure that we're sharing this evidence with people that matters. And I think that's the next round of agronomists and advisors which are coming out. So I really hope the evidence is being shared in a really accessible way for them to be able to share it with their clients and in those farming communities as well. And I hope that we've moved on from that kind of more old school approach. And it's bloody easy to say stuff doesn't work, right? And it's really hard to show why something does work. But farmers are the best people to do that. And just seeing the momentum, like at your field days, Ellie, and the interest and engagement from a range of different audiences in that space. Organizations like Vic No-Till, I think it's such an exciting space to be in. But then, hey, still people just want to stand around and dig a hole and have a look in the ground. And I think that's still the best.
Yeah, that's fun. We want to get our hands in the dirt. Thank you so much, Suze. It's been an absolute pleasure chatting with you. It's something I've wanted to do for a long time. And so, yeah, really appreciate the time you've taken to come and share all of your thoughts on the Source for Life podcast.
Thanks for having me.
This episode was hosted by me, Ellie Court, and produced by Chris Swiffering. If you enjoyed this episode, please take the time to give us a rating in Apple Podcasts, Spotify, or wherever you're listening. And if you know of someone who you think we should get on the pod or have any other feedback, please let us know by email info@soilsforlife.com. biomass.org.au. Thanks for listening.